with chapter 2. Our next topic is equipotential. Surfaces. Definition. An equipotential surface is a surface with constant value of potential at all points. On the surface. This means that if we have a surface, any shape, the potential at every point, let us say this point P1, point P2, point P3, the potentials will be same. If here it is Vp, again it will be Vp here, it will be Vp here, anywhere on the surface. It means that that the potential difference, let us say Vp1, Vp2, Vp3, Vp1 minus Vp2 will be 0. Because at everywhere the potential has the same value. Okay? Now, let us examine its properties. Property number 1, as already discussed, is potential difference delta V between 2 points, any 2 points on the equipotential surface. Let us say point A, it is VA, and point B, it is VP, is equal to 0 because VA is equal to VB. Property number 2. No work is done in moving a charge from one point to another on an equipotential surface. We know that work done per unit charge is equal to the potential difference delta V. Now, for equipotential surface, delta V is 0, which implies that W by Q is equal to 0 or W work done is equal to 0. So, work done in moving, अगर यहाँ से यहाँ तक लाएंगे, क्योंकि there is no potential difference, hence no work, electrical work will be done. Okay. Property number 3. Property number 3. We know that small work done in moving a charge dW per unit charge, let us say test charge, is equal to E dot dl, or dW by Q is equal to E dl cos of theta, because E dot dl is equal to E dl cos theta. Now, as no work is done in moving a charge in an equipotential surface, so for dW is equal to 0, which implies that 0 by q is equal to 0 or E dl cos of theta is equal to 0, which implies that cos theta is equal to 0 or theta is equal to 90 degree. That means electric field is always perpendicular to the equipotential surface. Okay, E and dl are perpendicular direction में होगा. Number 4. Now E is equal to dV by dr, which we will drive next in the next topic, dV by dr. This is called the potential gradient. Now, for a given equipotential between the potential difference between two surfaces, equipotential. Let us say this is one and this is second. Surface number 1, surface number 2. Okay, this is the potential difference. There will be some potential difference between two surfaces, लेकिन खुद surface पे 0 होगा. It means that E is inversely proportional to dr, that is the spacing, distance between these two equipotential surfaces, or dr is proportional to E. So, smaller the d, larger will be E. Larger the E, larger the spacing between the equipotential surfaces, smaller will be the E. And smaller the spacing between the equipotential surfaces, stronger will be E. So, in the region of strong electric field E, the equipotential surfaces are close to each other. And in weaker regions, separation is more. Next property number 5. Equipotential surfaces do not intersect. जैसे electric field lines do not intersect, इसी तरह से ये भी. For example, we have this equipotential surface. Let us say this is surface A and another equipotential surface B. Let us say these cut at this point and this point. Suppose this here in this surface potential will be same because of equipotential surface. Let us say कि इसमें यहाँ potential B है, तो इस सभी पे B potential B है, लेकिन इस पॉइंट पे हमें VA भी आ रहा है और VB भी आ रहा है, क्योंकि ये दोनों का हिस्सा है, इसका भी और इसका भी. So which is not possible. Hence, equipotential surfaces do not intersect. Next is shapes of equipotential surfaces for different charge distributions. यानी कैसी शेप्स होती हैं अगर चार्ज हमारे पास पॉइंट चार्ज है या कोई यूनिफॉर्म फील्ड है या डाइपोल है या टू सिमिलर चार्ज है, तो कैसी इक्विपोटेंशियल सरफेस होती है. नंबर 1, फॉर शेप ऑफ दिस equipotent surface for an isolated point charge. Suppose we have a point charge here plus Q, so field lines will be radially outwards. Now let us draw it another time. Here we have a plus charge. Now we know that for point charge V is equal to KQ by R. Now since Q, let us suppose this is Q charge, point charge Q, which will be constant, K is also constant, so V is inversely proportional to R. Now for a fixed R, if R is fixed and a constant, that means V is also constant. So if I draw here a point which is distant R from this, then we will have a sphere like this, which is equidistant from the center. Okay, so यहाँ से भी R है, यहाँ से भी R है, यहाँ से, तो potential will be constant because R is fixed. इसी तरह से अगर यहाँ एक और ले लूँगी इस तरह से, ये सेंटर ऑफ चार्ज से यहाँ इतना, इसकी लेटर से R डैश है, ये भी कांस्टेंट इस पूरे स्फीयर में जो इसके इर्द गिर्द सेंटर्ड अराउंड द चार्ज, ये यहाँ पर सभी इस सरफेस पे पोटेंशियल कांस्टेंट होगा. सो for a point charge which is isolated, the equipotential surfaces are concentric spherical surfaces centered at the charge. यानी फिर से बनाता हूं, अगर ये चार्ज जो है तो इक्विपोटेंशियल सरफेसेस इसके इर्द गिर्द स्फीयर्स होंगे. This is, let us say, R1, this is R1, let us say this is R2, R3. जैसे जब हम 4 से आगे जाएंगे तो फील्ड वीकर होगा, स्पेसिंग इनमें बढ़ जाएगी. इसको यहाँ पर 1 सेंटीमीटर है, यहाँ कम होगी इस और इसके दरमियान. सो क्लोजर द इक्विपोटेंशियल सरफेसेस और स्ट्रॉन्गर विल बी फील्ड एंड स्पेसिंग विल बी लेस. जैसे दूर जाएंगे तो स्पेसिंग बढ़ जाएगी. Point number 4. Shape number 2. For uniform electric field E, say along x-axis, equipotential surfaces will be planes normal to x-axis or parallel to y-z plane. That will be like this. Suppose we have this as axis, this is x-axis, this is your y-axis, and this is z-axis. Now let us suppose that we have an equipotential surface which is parallel to y-z plane. Now we will have another equipotential surface This is surface 1, this is surface 2, this is surface 3. B will be equidistant because the field will be parallel to x-axis. So अगर यहाँ पर V1 है इस सरफेस पे पोटेंशियल, ये सारे हर एक पॉइंट पे V1 होगी। यहाँ पर अगर V2 पोटेंशियल है तो हर एक जगह V2 ही होगी। अगर यहाँ पर V3 है पोटेंशियल तो हर एक इस सरफेस प्लेन सरफेस पे V3 ही होगी, ठीक। और स्पेसिंग इनके दरमियान इक्वल होगी बिकॉज दिस इज यूनिफॉर्म फील्ड। यहाँ पर कहीं फील्ड की वेरिएशन नहीं आती, इसलिए ये भी सरफेसेस भी इक्विडिस्टेंट। So these will be planes parallel to YZ plane if field is along x-axis and is uniform, and the planes will be equidistant. Okay. Similarly, if we have let's say a dipole, shape of the surface will be, let us say this is minus, this is plus. Okay. So this will be closer, यहाँ पर closer होंगी, फिर थोड़ा दूर दूर दूर, इसी तरह से यहाँ पर भी क्लोज होंगे चार्ज के, फिर थोड़ा दूर दूर, ये कॉन्सेंट्रिक सर्कल्स ऐसे। ठीक है। सो ये भी इक्विपोटेंशियल सरफेस होगी, ये भी, ये भी, ये भी, ये भी, ये भी, जैसे यहाँ पर थोड़ा साथ साथ होगी फिर दूर हो जाएंगे। इसी तरह से अगर हमारे पास 2 लाइक चार्जेस है, प्लस एंड प्लस, 2 लाइक चार्जेस, उनकी कैसे होगी? उनकी भी ऐसे कुछ होगी, ऐसे यहाँ और कुछ ऐसे इस शेप। So these will be shape of this equipotent surfaces for 2 like charges. Next topic. Relation between electric field E and potential difference V. That is E is equal to dV by dr. This is called dV by dr is called as potential gradient. Okay. Now, ये हमें रिलेशन प्रूव करनी है. Let us suppose that we have an equipotential surface this is surface B and this is surface A. Okay, इस सरफेस पे पोटेंशियल V है, इस पे पोटेंशियल V माइनस डेल्टा V. थोड़ी सी नजदीक है, थोड़ी सी फर्क है पोटेंशियल में डेल्टा V. यहाँ पे सरफेस 2 पे पॉइंट है P and we want to move the charge through a small distance which is spacing between these two surfaces, that it will be delta L. Okay, now assuming that something has produced electric field here which is in this direction. Okay, now here the field will be stronger, potential will be more, and here potential will be less. It is delta V minus delta V. Now let us suppose that we have here a unit positive charge plus 1 coulomb, and we bring it down against the electrical field, because electric field will be in this direction, upward direction. Okay? Now we bring a unit positive charge from this point in the surface B to the surface A through a perpendicular distance delta dl. Then what will be the work done? Then work done dW in moving unit positive charge from surface B to surface A is equal to E dot dl. Okay. Now we know that E dot dl by the definition or work done per unit charge is equal to, क्योंकि unit charge है इसलिए यहाँ पर मैंने क्यों नहीं लिखा है. So work done will be equal to E dot dl will be equal to VA minus VB, that is potential at A minus potential at B. ठीक है, फाइनल पोटेंशियल माइनस इनिशियल, तो हम यहाँ से ला रहे हैं चार्ज को. सो दिस विल बी इक्वल टू E delta L cos of theta, which is equal to VA minus VB. Now cos theta is equal to 0 since we are moving in this direction. So cos theta will be 0, so cos theta will be equal to 1. So E delta L is equal to VA minus VB. Now what is VA? That is V. What is VB? V minus delta V. So we get E delta L is equal to V minus V plus delta L. Okay, or E delta L is equal to this, and this will go delta V, or E delta V by delta L, or delta, if delta this is very small, limiting value, E will be or dV by dL. This is the relation, dV by dL is equal to E. So what does this mean? This means we could have also written this as minus. It would have been minus. It will be same. No. Now what does this relation tell? ये जो dV by dL इसको कहते हैं potential gradient, fall of potential with respect to distance. Number 1. Electric field E is in the direction in which the potential decreases steepest. क्यों? देखिए, E इस डायरेक्शन में है, पोटेंशियल डिक्रीज. जैसे हम जा रहे हैं यहाँ से, तो पोटेंशियल कहाँ, हम जा रहे हैं यहाँ से यहाँ तक, लेकिन पोटेंशियल कम कहाँ है, यहाँ. ठीक है ना. सो यहाँ से स्टीपेस्ट ये डिक्रीज, बट फील्ड इज अपोजिट टू इट, इस डायरेक्शन. पॉइंट नंबर 2, its magnitude, that is magnitude of E, magnitude is given by the change in the magnitude. Its magnitude is given by the change in the magnitude of potential per unit displacement, normal to the equipotential surface at the point. यानी its magnitude, the magnitude of E here, magnitude of E is given by the change in the magnitude of potential per unit displacement. Change in potential, that is dV. Per unit displacement is dl. Normal to that point. तो E कहाँ है? It is normal to this. जो चेंज में आती है उसके नॉर्मल होता है आपका फील्ड इस डायरेक्शन में, जैसे यहाँ पर मैंने फील्ड इज इन दिस डायरेक्शन.